So very good day to everybody once again. This is technological innovation and new media, and in this class we discuss about the quality of service aware routing and then resource reservation protocol even. So this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So once again, I would like to thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students, and young researchers. So in this class, we discuss about quality of service and then multimedia, about the various QoS specifications. Then we define about differentiated services and then integrated services, that is diff-serv and then IntServ QoS components. Then we discuss about the call admission procedure, how you try to stream the live multimedia, about the resource reservation protocol in the RT or maybe real-time systems. Then we discuss about the reservation messages, about the RARP, reverse address resolution protocol, about the RSVP operation. And then, as I told you, I've already posted the independent work in the Google Classroom. Please submit them. You've got just 1 month to complete them. 1 month and then some 12 days to complete them. Okay, so submit as early as possible. 5 independent works and then 1 open-ended project work. So at regular intervals, I'll be giving you some videos to discuss the knowledge in our topics. Right. Whenever you refer to quality of service, it is nothing but you are going to control the traffic and you are going to assure the best means possible, the efficiency to the networks. So through the traffic control mechanisms, we can differentiate the performance based on the application it is being fed to, or maybe the network and then operator requirements. So you are providing a guaranteed service or maybe guaranteed performance to the applications, to the time slots, to the sessions, or maybe through the traffic that you are going to aggregate. Okay. So basic thing is, with regards to quality of service, you have to reduce the packet delay and you have to reduce the losses, what you call to be jitter. Okay. So for the quality of service, you have to have the delay within the threshold limit, and then the loss rate should not be high. So with the case of audio streaming and then video streaming, we will have packet loss rate within the bounded limit. Okay, and it will not be sensitive, too much sensitive to the delay problem. So here we have the time critical applications where you consider the delay to be fitting onto a threshold limit. Okay, so the applications should be provided better services than the case with the least means possible applications. So here quality of service specification is can be specified in terms of following parameters like delay, the variation of delay, what you call to be jitter, the throughput, the maximum amount of data that can be transmitted within the specified time interval, and then the error rate. Okay, so for this we propose the solutions: stateless solution and then stateful solution. Okay, so for the stateless, as the name implies, there is no state, which means there is no fine-grained state about the traffic, and only the positive thing about this one is that it is measurable and then it is robust and reliable. Okay, so since it has weak services, there is no guarantee about the kind of delay it will introduce. It might introduce delay at any point of time. Also, it will be degrading the performance because it doesn't have any state. Okay, so this is the problem with the stateless solution. With the case of stateful solution, we are having a standard or maybe per flow rate as well. So there are guaranteed services because we have state. Okay, and definitely there will be higher utilization of resources. It will be providing security, authentication, privacy features also, and definitely it is less scalable and robust even. Okay. Next we have IntServ and then diff-serv, integrated services and differentiated services. So we have an architecture for providing quality of service in the IP networks. So here we will have the RSVP block, we'll have the policy control, admission control, we have the packet classifier for classifying and then scheduling also takes place. Through this, it goes to the application layer. From the packet scheduler, it goes on to the network for the transmission. So the IntServ it is completely relying on the resource reservation, and definitely it has to maintain a state because it is stateful solution. Okay. So all the information about the resources and the call setup request has been taking place, and it is going to decide whether it is going for admission control, whether it can accept or maybe deny a new call setup request. Okay. So the QoS component will be having call setup signaling, traffic, quality of service declaration, per element admission control also. So here in the IntServ or integrated services, we'll be having weighted fair queue discipline as well. Also, we'll have quality of service sensitive routing algorithm. Okay, so that is the algorithm that it maintains, QSPF, and then quality of service sensitive packet discard strategy. So it removes or maybe eliminates the unwanted packets, and it will be providing accordingly. Right. So next we'll go with the RSVP internet signaling. So here we will have the data flow from the router. It will we will be having or we'll be connecting to several routers. We will be having a merge reservation, okay, going on, and reservation messages will be from the different host. Okay. So here it will be creating and then maintaining distributed reservation state, which is actually initiated by the receiver, and it is going to scale maybe like a multicast version of transmitting. Okay. And it will be deciding whether it will be in the soft state. So the paths will be discovered through the path messages, okay, which is nothing but in the forward direction, and if of course it will be used by the reservation messages even reserve direction. Okay. So for the call admission, the session must first of all declare its quality of service requirement, and it has to characterize the type of traffic. Okay. So for this one, we will have R spec and then T spec and so on. Okay. So for the R spec, it is nothing but R specification. It is nothing but it is defining the quality of service being requested. Okay. And it is going to define what kind of bound we want on the delay and what kind of packet loss it is acceptable, so that we will be specifying in the R specification. Then you have T specification, nothing but traffic specification. So here it is going to specify the traffic characteristics like burstiness of the traffic. So here we will have both the R spec and then T spec for the routers whenever the reservation is actually required. Okay. So here the routers will actually admit calls based on the R specification, T specification, also based on the current resources which is allocated to the routers to the other calls. So here we will be having site 1 and site 2. We will be having VPN, L2 VPN, or maybe RSVP unaware cloud event. So similar to in integrated services, we will be having differentiated services. So it is actually considered as a stateful solution, not a stateless. So every flow doesn't mean that it has a different state. Okay. So it has the common solutions and it provides the reduced state services. So here it is going to maintain the state only for large flows rather than the end-to-end flows even, and that will be achieving the services. Okay. So you will have flexible service models, and you will be having qualitative service class also, and you have to provide the relative service distinction. Okay. Then of course we have simple signaling as well, where the applications and users have to specify a more qualitative notion of service. So this is how you try to stream the live multimedia. We have the internet, radio, talk show, and then live sporting event even. So that you can transfer the data at a very fast speed. And of course for streaming, you can make usage of the playback buffer even. So that can lag maybe tens of seconds. Maybe if you are seeing a live football or maybe live cricket match even, like you can you cannot forward, but you can definitely lag or maybe go backward, even go rewind, and maybe if possible you can pause even. Okay, but you cannot go forward. So next is the resource reservation protocol, RSVP, that you can use it in the real-time systems. So maybe in the receiver side, for faster delivery of transmission packets from the sender to the receiver, you can use them. And of course, it is still associated with the receiver. So it is actually initiated at the receiver. So it is a receiver initiated. And of course, receiver node is actually initiate the entire process for the real-time systems. So here we will have admission control and then request messages and reply messages. So admission control is being set up like S1, S2, S3 and S4, S5 even. Source node and then destination node. So with this one, the request message is passed on and to the admission control, and then we will be having the reply message to the destination node. So RSVP or maybe resource reservation protocol, it is unidirectional or maybe simplex mode, and receiver node receives the packet and does not want to send any data. And the quality of service is provided by the RSVP, and admission control is used for each hop that it uses in the network topology. So here we will be having classification, buffer management and scheduling process event, and it is going to dynamically adapt to the change in the route for the efficient message transfer. Okay. So it's actually not a routing protocol, but for each hop that you can use, it permits the admission control, and it entirely depends on the other routing protocols that it uses. So here we will be having flow specification and filter specification in this differentiated services. So maybe for flow specification, maybe for the bandwidth, for the link strength, or maybe for congestion, maybe for smooth or maybe without any collision, like the communication and data transfer, you can use the flow specification. And also the filter specification, you can use it for filtering of the packets. Okay, so the packets are being routed according to the destination type, maybe as a fixed or maybe shared receiver, and you can use reservation messages even to the sender, which specifies all required resources and parameters for the reservation to establish. So these are the reservation messages. Okay, like we'll have the path message. So when you try to receive the reservation message, the sender is going to record all the resources to be reserved. Okay, and it is going to record the path even. So the sender will be multicasting a path message to all the receivers, which is going to specify the routing details of the packet. So here it will be containing all the necessary specifications about the reservation to be made for the receiver. Okay, so you will have sender, receiver 1 and receiver 2. Here you will be having reservations to be sent maybe from receiver 2, okay, to the reservation, receiver 1 a reservation, it is going to the sender. So this is how it goes, like sender again after receiving, then it will sender the path to the receiver 1, sender through the path to receiver 2. Then you have RARP, reverse address resolution protocol. So here the data which is being sent is actually preserved or maybe protected to prevent the data which is being sent to the receiver from the breach. So here error reporting is actually done at the sender side. So maybe for making any changes in the communication strategy, you can use this one. And maybe if in case the RSVP fails, then the admission state is actually sent to the requester for handling the necessary packets. So here you will be having like the host and then RARP server. Okay, so maybe after receiving the request, it will be sending the reply. Like this is the IP address like 162.12.42.2, and the reverse address resolution protocol. The reply is actually one way, like a unicast. Okay. So in RARP, the routers is going to record the necessary forward as well as reverse routing state, and it will be making necessary changes in the path message that is being sent by the sender to the receiver to actually indicate the resource availability. So here actually the host is going to send the data within the specific QoS. So it will be sending a RSVP path message for every 30 seconds. So naturally it will travel maybe like unicast or maybe multicast routes even, and that has been pre-established by the working protocol. Okay. So the path message which arrives at the router does not actually understand the RSVP, but definitely it will forward the message without interpreting the contents of the message. Okay. and it will not reserve the resources for the flow. Okay, so maybe those who want to listen them, maybe they can use to send the corresponding reserve short message. Okay, and then it is going to trace the back to the sender event. The reserve message will be having the flow specification, flow spec, and reserve message also has a filter spec, filter specification object that is going to filter all the packets. So it will be receiving the requested QoS defined in the flow specification, and a simple filter spec will contain the sender's IP address, and it will be having maybe or may not be a user datagram protocol or maybe transmission control protocol. So when the router is going to receive the RSVP reserve message, generally it will make a reservation based on the request parameters. Okay, so from the source, router A, router B to router C, router D, everything will be having the receiver substation R1, R2, R3 and R4. So like a 20 kbps, 100 kbps, 3 mbps and 3 mbps. Then you will have admission control that is going to process the request parameters, and it can instruct the packet classifier even. So to correctly handle the selected subset of data packets. So how the packet handling should be performed? Maybe if it cannot be supported means it will be sending a reject message. Okay, and then you will have the important phenomena, which is nothing but it will be forwarding the request upstream. So that will be the forwarding takes place in the direction of the sender event. So for each node, the flow specification in the reserve message can be modified by the forwarding node, and the routers will be storing the nature of the flow that is processing, and it will be setting up a policy according to the flow specification. Maybe if nothing is heard for a period of time, the reservation will time out and definitely it will be cancelled. So this you can solve it if either the sender or maybe receiver may be crashed or maybe shut down without cancelling the first reservation.